Hi and welcome. This time around we have a quick project to expand some workspace in the shop. But first we have a couple stickers, Mick's Workshop and Ed Cood's Workshop, EC Workshop. Check out the YouTube channels. Very excited to add them to my sticker board. Alright, here they are at their new home on my expanded sticker area. Second two stickers. So space is incredibly tight in my shop. This is my Delta Unisaw and I can hardly get to it most of the time because I've had it double up as a welding table, but I didn't want to weld right on the cast iron surface of it. So I made this T-slot insert here out of steel, and I take a piece of 1-inch plate aluminum, use these screws and just bolt it to this surface right here. So let me put it back. And with a couple thumb screws tightening into the T-slot insert that I made right here, you can slide this thing back and forth, and the advantage is I can have it stick out farther than the table sticks out, which gives me more surface area. Then I started using this to attach various tools to this plate to try and bend, but everything is so tight here. You can see where I store water there, and then this is pantry storage here. There's hardly any room here between here and here. So when I was putting my tools here, especially the rotary bender that these 3 holes were for, there's just not enough room, so I need to find another flat space I can utilize. So that's when the next idea came to mind. Similar to this one, because this is very useful to weld on. By the way, when it sticks over the edge, it gives you a great place for your ground clamp to go multiple locations. It's very handy. Also, one final problem with the Unisaw is the Unisaw is on a mobile base. And even though it's locked off to these tiny plastic wheels, and if you really yank on this with any effort at all, the whole thing moves on me, which is no good because there's really not much room for it to move, so it just ends up bumping into things like my surface grinder over there. This really is a tight spot. Thus brought me to my next idea, which is another flat surface that isn't occupied most of the time because I'm of course trying to use it as a saw. The advantage of this guy is it weighs 1,500 pounds and the base is right on the floor, so there's a reasonable amount of friction. It doesn't slide all that easily. And so I thought I would try and utilize this to mount the tools that need to have a fair amount of force applied to them, and thought I'd follow the same route. So here's some more 1-inch tooling plate, and this material here is so I can grab under the 1-inch top steel, the steel top on both sides, and we're going to turn this into a removable surface to mount on top of here. And the reason why I've got the tooling plate is because I didn't want to drill holes in my steel Blanchard ground top because it's beautiful and it would just mar it. It probably wouldn't affect its functionality, but it's better to leave it smooth. So we're just going to have this guy boltable onto the side here and make it usable. And that's what the project this week will be. Very simple but useful, and hopefully the idea will help some of you. I purposely chose plate that will overlap and stick out because, again, if it sticks out a little bit, it gives you more space than you had before by stealing some of your free walking space. But heck, I can edge by here, so that's all I need to do. So I could have even gotten a bigger piece than this, but I think this will work. In case you've forgotten, I've got a bead roller here. I've got the Eastwood brake here. I have a bender right here. And I have a shear right here with a really long handle. And all of these tools would benefit from being bolted down, but there's nowhere to put them permanently. So you need to make a removable design, and that's what I'm working at. So first job is to get these horrible stickers my metal supplier puts on all of their parts. They claim they need it because they're ISO certified, so they can't use adhesive that actually comes off easily. Instead, it leaves gummy residue on top of everything. So you gotta spend like a half an hour with acetone when you're using cutoffs like this. Fortunately, it's cheaper. Interestingly enough, this extruded aluminum was more expensive, that's a cutoff, was more expensive per pound than this Blanchard ground tooling plate was per pound by about 50 cents a pound, which is really weird because this stuff is precision thickness. First up, we're going to cut a chunk of this material off. That's enough for 2 clamps, about 3 inches each. Next up, we want to hog a whole bunch of material out of here. It'd be nice if you could bandsaw it, which I probably could, but That's an interesting thought. I want to remove about 1.5 inches of material wide by 925 thousandths deep. That's a pretty big spot. I wonder if I could cut this off in my bandsaw. It has the height capacity. I decided to try and remove a majority of the material by sawing. So we're going to do that. I think it might even be faster. That big clunk you're hearing is a bad weld in the blade. They didn't do a very good job. Oops. I didn't believe there was much in the way of stress, residual stress in extruded materials, but this guy closed up on the blade. And I had to tap it off gently with a hammer. Never seen that one before with aluminum. Live and learn. Second cut. That's it. Left just a tiny little ridge sticking up. Hopefully I can work harden this off, or I might have to come back with a saw, like a hacksaw, and just cut through there quickly. I'm not sure that was faster at all, but I did save a big chunk of material that I could reuse for something else. So that's a plus. Now we just need to drill 2 holes all the way through, and these holes will be for mounting. The thumb screws are going to come from the bottom and thread into the plate and not protrude. Originally I thought I was going to go through the plate and into this material and thread here, which I could, but then the thumb screws might be in the way, so they're better to have on the bottom. So we're going to go for that. And we're there. After playing around with these clamps for a little bit, they work fine, but when you tighten them, because there's only one point of fastening, they tend to rotate. So I'm going to put a pin in a random spot on each of these so they're not interchangeable. That's not important. So we're going to drill through with an undersized drill bit. We're going to take this piece off. We're going to ream the bottom and with a 2/1000 press fit. And then we're going to drill all the way through for the top part so that it just has something to slide, so it can only rotate a tiny bit, because it's very annoying when you're trying to tighten it down. This thing's rotating all over the place. So I'm going to do that to both sides of this part, and that should fix my problem. Now we're going to pop this guy off and ream the bottom, and then we'll drill through the top. Slightly oversized. We're going to give a little bit of slop on that one. We don't want it to be a tight fit because it is aluminum, so without a bushing in there, it's going to be kind of sticking. And we're done. By the way, here's a quick vacuum mod. So I took this suction piece here, which normally sticks in all these rubber bits and it's a pain to get off. And I drilled a hole in the end here so it allows a bypass, and you just keep your finger over it and lift off once it starts sucking. And it still sucks pretty well even with the hole not closed, but if you need that extra boost, you can. And then when it grabs, you can just let go and things pop off. Very convenient. Now I'm just going to drill out the pinholes in this side to be sliding fit. So we're going to drill them out 3/8. I might even go a little bit bigger. We'll see. And I'm finding location by just taking one of the pins and chucking it up, since I didn't do it by measuring. And there we go. The drill bit left kind of a nasty finish inside, and it was kind of snug, so I opened it up to 0.377, and now we've got a very nice fit. And it's sliding, so I think that should work. If I need to open up more, I can, but I think we'll be all right. So here's the table in place. And now I just need to lay out for all the tools and the screws that are going to go into them. There's the thumb screw down below. I might need to make a tool to tighten those thumb screws just a little bit more because they need to go just a little bit past snug or larger diameter, but there are some clearance issues up front here, so that may end up being a problem. But the table's working out great so far. Let's get some tools on there and do some layout. First tool for layout is going to be the bender, and I'm using a transfer punch to mark the material where I would drill and tap. And we'll just move on to the next tools, and I'm going to try and reuse screw holes where I can, but like the transfer punch, I need a lot of swing over here, so it needs to be out towards the edge. And that's one of the advantages of being able to pull this to the side. Now this piece comes off, so if the arm needs to go all the way around, I will be able to, plus the fence comes off of here. So that's pretty handy. And this can slide in or out as necessary because that's how I designed it, rather than just bolt it directly to the table, which was another option. The bolting of the table would make it a lot more steady when you're really cranking on it, but I really didn't want to damage the table. It's so beautiful, plus it's hardened, so that makes it kind of challenging. So I was wondering how I was going to clamp this guy down while I drilled all and tapped all these holes. And then I thought to myself, you know, it's actually an easier solution to this. I don't care about extra holes in this at all. Now putting the pins in early was stupid. Now I have to have it raised up on 1, 2, 3 blocks because the pins stick down too far and everything's marked on the opposite side. The pins are sticking up. So that was a brilliant choice on my part. I don't know if you can see the pins here, and here. They stick down a couple inches. But in any case, I can just drill a couple half-inch holes and then just run studs to the mill table directly with the T slots and hold these things up. So I'm going to drill a couple half-inch holes here, and then we're going to get about drilling and tapping all these. As you can see, just run the bolts right through. I put a couple extras over here so I can flip the part around either way I want. Right now I have them all the way over in the far slot, but I can put them in all three. It makes it really convenient just to drill these in place. All I'm trying to do is get a rough alignment of these. I'm not trying to get a precision anything. To make power tapping a little bit easier, I have a chart that has 75% threads and 50% threads roughly, and I actually went halfway in between them and went 60-some% threads. Normally you do 75 for aluminum, but this is 1 inch thick. Finished all the holes over here. Now I'm going to repo to do these holes. To save myself having to reposition the plate front to back, since this is wider than my table travel, don't forget that on Bridgeport the ram can go in and out. So I just moved the ram to get these far ones. I'm going to pull it back to get the one back there. And this hopefully concludes the drilling and tapping part of our program, and we'll move on to fitting. Hopefully I got it right. Tool number 1, tool number 2, tool number 3. With its very long arm that will now stick out way across the shop but work perfectly. Also, I can build a shelf over here if I want to support stock coming in. Plenty of room here. And last but not least, the brake. Easily fit over here. And I don't have this bolted all the way down here, but you can see that we've got easy access to the handles here and here. So we are looking good. And that's it until I get my next tool that I need to add here, and hopefully it'll fit here as well. Maybe I should have gone with a larger piece of plate. This was kind of the largest one I could find without having a custom cut slice. The 1 inch thick depth makes it so that I don't have to be so careful with my through length, so I can use generic screw lengths. And overall, I think this project turned out pretty useful. I did not chamfer the edges on this yet because I have another tool coming that I want to do that with, and I will save that for an upcoming video. When I'm done, take the screws, screw them in the top to store them, tighten the bottom blocks just gently so that protects the pins. Take this guy off the table, stow it right here next to the table so that it's under the shadow of the tabletop so I won't run into it more than once or twice a week, and we're good to go. Hope you find it useful. Hope to see you next time. Thanks for watching.